Alright, so let's talk a little bit about benzodiazepine and the chemistry of it, or the structure-activity relationship, or SAR is what we call it. So benzos are usually used for anxiety. This is supposed to be like short-term, like say someone's transitioning onto an SSRI and they're having periodic anxiety, like an increase in anxiety as they're starting the medication. We'll give them a benzo PRN for or as needed for a little bit while they're starting it. It's also appropriate for as needed or PRN for panic disorder. We don't really use it like scheduled every single day for patients anymore due to the addictive potential and then the long-term side effects of cognitive decline and falls in elderly patients. So also we use it like as needed for like plane rides and stuff. But some patients actually use it for insomnia. This isn't really recommended anymore either. And then we also sometimes use it for seizure disorder. Status epilepticus is when you have like a seizure that doesn't stop lasting more than like 5 minutes. Benzos are sometimes used perioperatively, like midazolam for sedation, or anxiolysis in like the ICU setting. I also see it for alcohol withdrawal acutely with patients, and then it's also used for chemo-induced nausea vomiting with some patients, namely lorazepam off-label. And then also we'll use it sometimes for overdose for like stimulants like Coke. So we classify them into like 3 categories: short, intermediate, and long-acting. So short-acting would be like a duration of action about 2 to 8 hours. This would be like midazolam and triazolam. Triazolam is used for sleep, sometimes for like procedural, for like a tooth extraction. Intermediate acting would be a duration of action about 11 to 20 hours. This is like alprazolam or Xanax, lorazepam or Ativan, and then as well as astazolam, oxazepam, temazepam. So temazepam is used for onset and maintenance insomnia sometimes, versus again triazolam, which is just for onset insomnia and procedural usage. Long-acting benzos, duration of action about 1 to 3 days. These have pretty long half-lives. This would be your diazepam or Valium, your clonazepam, Klonopin, and then also clobazam, chlordiazepoxide I'll talk about, and then clozapam, chlorazepate, flurazepam. So chlordiazepoxide was the first benzodiazepine. It was marketed in 1960. It's not as potent as Valium, which was marketed 3 years later, and it was actually the top-selling pharmaceutical in the 70s. But chlordiazepoxide has multiple active metabolites. Demoxapan, all the way at the top right, has a half-life of 14 to 95 hours, and then it metabolizes into nordiazepam, which has a half-life of 36 to 200 hours. So that's kind of wild. Nordiazepam is the same metabolite that Valium metabolizes into. That's important to know. That helped me get someone out of jail. So here we have a picture of some long-acting benzodiazepines. You see the little carbon group on the nitrogen up here. It's by the carbonyl. That little N-methyl group increases the duration of action and half-life. So it lasts longer. It lasts longer in the body and then undergoes hepatic metabolism. So in order, the top left structure is diazepam or Valium. The top right is clonazepam. The bottom left is clobazam. And then the bottom right is actually roofies. This is flunitrazepam or Rohypnol. It was marketed in the 70s for medical usage. It has no taste, and it has a lot of anterograde amnesia. It has a rapid onset as well. So again, we have Klonopin up here. It has that little electronegative halogen, that little chlorine. That increases potency in GABA-A allosteric binding. It has a little fluorine over here, another little electronegative halogen. And then this little nitro group over here in the A ring system also increases potency. It's more potent than if it were a chlorine, like with these other 2 structures like Valium. I ripped this from my notes, but these 3 medications, lorazepam, oxazepam, and temazepam, don't require a lot of hepatic metabolism. So they're not heavily hepatically metabolized, so they're better for patients with hepatic or liver dysfunction. This is due to this little hydroxyl group at the right, that it undergoes only phase 2 metabolism, really. So phase 2 being like conjugation reactions, like amino acid or glutathione conjugation, glucuronidation, sulfation, and acetylation. As opposed to like phase 1 metabolism that a lot of drugs undergo. It uses the CYP450 system, like if you've heard of like, I'm a poor extensive CYP2D6 metabolite or stuff like that. Phase 1 uses reactions like oxidation, reduction, deamination, dealkylation, N-oxidation, hydroxylation, desulfuration, sulfoxidation, stuff like that. So because of this little hydroxyl group, the little OH on the far right, that increases polarity to the group, which also leads to a slower onset of action because it has a slower cross into the blood-brain barrier, and then it also decreases the duration of action. So I will mention 3 most potent benzos are Klonopin, alprazolam, and lorazepam. In school, alprazolam was called the crack of the benzos. It has an extremely fast onset. So addictive potential with medications usually comes from the speed of the onset. So like if you snort or inject something, it's going to be more addictive, like if you like just swallow it. And then it also has to do with like lipophilicity, blood-brain barrier penetration, and then potency and receptor affinity. Those will also add to addictive potentials of medications. Receptor affinity being how strong does it bind to the receptor.